The next chapter that we deal with in physics is thermal expansion and calorimetry. This chapter consists of very simple questions and there are only 2-3 formulas which you need to apply to solve the questions. You just need to learn to apply these formulas properly. So in this question that we have, there is an aluminium container of mass 100 grams and it contains 200 grams of ice at minus 20 degrees Celsius. The system is at thermal equilibrium, that means the aluminium container is also at minus 20 degrees Celsius. Now heat is added to the system at 100 calories per second. We need to find out the temperature of system after 4 minutes. Now you should know first one thing, that at thermal equilibrium the temperature of the whole system is same. Now let us first check as to what happens, as to how much heat is required by the object to go from minus 20 degrees Celsius to 0 degrees Celsius. Now there is an important thing about 0 degrees Celsius. Ice can exist in the form of ice at 0 degrees Celsius, or it can exist in the form of water at 0 degrees Celsius. So we convert the system from aluminium plus ice at 20 degrees Celsius to aluminium plus water plus ice, again let it be ice, at 0 degrees Celsius. This is minus 20 degrees Celsius. So from aluminium plus ice at minus 20 degrees Celsius to aluminium plus ice at 0 degrees Celsius, the amount of heat required to be given to the system for this to occur is equal to the mass of aluminium, that is given to be 100 grams, into the specific heat of aluminium, that is given to be 0.2, into the change in temperature, that is 20, plus the same thing for ice. The mass of ice is 200 grams, into the specific heat of ice, that is 0.5, into delta T, that is 20. This comes out to be equal to 400 plus 2000 is equal to 2400 calories. Now the time this takes is equal to 2400 upon 100 calories per second, that is equal to 24 seconds. So we are done with only 24 seconds now, and the total time that we have is equal to 4 minutes. So we can heat the system more. So now our system is aluminium plus ice at 0 degrees Celsius. Let us convert this to aluminium plus water at 0 degrees Celsius. So the amount of heat required for this is equal to the mass of ice into the specific into the latent heat of fusion of ice. Whenever there is a state change, a heat is involved, that is equal to the latent heat of fusion, that is 80 calories per gram in this case. So this is the state, the change of states from ice at 0 degrees Celsius to water at 0 degrees Celsius is very important, because it consumes some amount of heat, but there is no change in temperature of the system. So be careful over here. So the heat absorbed by the system without change in its temperature is equal to 16,000 joule. Again the time taken is equal to 16,000 upon, it is 16,000 calories, sorry, and 16,000 upon 100, that is equal to 160 seconds. So we are done with 184 seconds now. Now the total time is 4 minutes, that is equal to 240 seconds. So amount of the time left for which we can do more heating is 240 minus 184, that is equal to 56 seconds. So in 56 seconds, the amount of heat that we will give is 5600 calories. Now the system was at aluminium plus water at 0 degrees Celsius. Let us see what happens when we give this much amount of heat to this system. Let it go to final temperature T. You must keep in mind one thing, that you can apply the equation for aluminium plus water at 0 degrees Celsius to aluminium plus water at T degrees Celsius directly by using the specific heats of aluminium and water, but you could not have applied this conversion directly from aluminium plus water at aluminium plus ice, sorry. You couldn't have applied the equation for aluminium plus ice at 0 degrees Celsius to aluminium plus water at T degree Celsius directly, because it would have also involved the term of latent heat of fusion. So for applying this, what we do is that we equate 5600, that is the amount of heat given. This is required to change this from this to this. Therefore, this is equal to mass of aluminium into specific heat of aluminium, that is 0.2 into delta T, let that be T, plus 200 into specific heat of water now into 1 into T. Therefore, on solving this equation, we get 220 T is equal to 5600, so T is equal to 560 upon 22, the temperature delta T. So the final temperature of the system after 4 minutes comes out to be 560 upon 22 degrees Celsius. This is our final answer.